Okay, so yesterday we had talked about orbitals a little bit. The orbitals were like the bunk beds in the Poggle. They were like the little circles where, the electrons were the circles, and then the orbitals were the bunk beds. Or, if you also remember, or they were this. One of those with the up and down arrow is an orbital. So that was what we looked at yesterday as an orbital. So, from that information, how many electrons can an orbital hold? Please and thank you, Sierra. 2. Yes, right. So, an orbital, I even put an S. That's messed up. An electron orbital, can hold 2 electrons. Okay? And you're going to be responsible. The shape of the orbitals are not a bunk bed. And they're not a line. They actually have a real shape, and you have to know what the shape is for each kind of orbital, for the S and the P. So they're pretty straightforward. S orbitals, we just made your test yesterday, so I know this is on the test. S orbitals, instead of looking like that, they're a sphere around the nucleus. Okay? They're a sphere. And then, that's easy to remember because it starts with S. And then p orbitals, their shape is like an infinity sign. Okay? Yes?
What's that thing? 2E what?
2 orbitals can hold 2 electrons. E is electron. Alright, now, let's think about this. The S block, you know we've been writing on these S's. 1 S2, 2 S2, 3 S2. How many electrons are in an S orbital? 2. If 2 can fit in one orbital, then there's only one S orbital. So like the 1s, do y'all have this now? Okay, so the 1s orbital, this looks like this. We're going to write it with a line, put 1s under it, and it can hold 2 electrons. Now you can draw lazy arrows. Let me show you how to draw a lazy arrow. Okay? That's how you draw a lazy arrow. Just like a half a, you don't have to come over here and be like that. If you don't like the lazy arrow, then draw a full arrow. But I'm just saying. So that's what the 1s orbital looks like. It can hold 2 electrons. So S orbitals, there's only one of them because you only have 2 electrons in the P block. 2 electrons in the P block, S block. There are 2 electrons in the S block. Both of them can fit in one orbital, one line. That makes sense? Y'all saw this yesterday with little boxes and the S bedrooms, the sunny bedrooms that can hold 2 people, and then the P bedrooms can hold 6 people, the pink ones. Do you remember?
Yeah.
Alright, cool. So, if I were going to draw a P orbital, let's make it 2P. Let me just say I'm going to draw this one. P orbitals. How many P orbitals do you think there are? Okay, well, there's 6 electrons in a P block. Each orbital can hold 2. So, how about 3? Does that make sense? Look, watch me. Do you remember yesterday how they could only one at a time feel like that?
Yeah.
So that's your 6 electrons, and they're housed in 3 orbitals. 3 times 2 is 6. So there are equals 3. 3 orbitals. Because there are 6 electrons in the P block. Anybody lost yet?
Yeah. Keep going.
Okay, if I do one, but do you understand that the S, there's 1 orbital because there's 2 electrons?
Yeah.
The S block's skinny, right? Okay, that's what we remember S with. And the P block is 6 across. 2 can go in each. 3, 4, 6, done. So, I mean, I don't expect you to be able to write one yet, but did you hang with me on that part?
Yeah.
Okay, so let me do an example, and I think it'll be fun. So let's do an orbital filling diagram for fluorine. Okay, so the electron configuration for fluorine, listen, it seems like a lot of work, but you already did the electron configuration like 5 minutes ago, so you're halfway there. You already did this part. So 1s2, 2s2, 2p5. So watch what I'm about to do. for the 1s?
1,
How many for the 2s?
3, wait, no, 2.
How many to draw for the 2p? Uh-huh. Let's all catch up with me. You good? Trent, you lost? Did I lose you? Okay. So watch. These are 2 electrons. 1, 2. Here's 2 electrons. 1, 2. There are some fancy names and principles we have to memorize, and I'm going to write those. There was Hunn's and alpha and Pauli exclusion. Okay? And in a second, if you remember which one's which, I'll give you a tick, but not yet. So 1, 2, 3, 4, 5. That is the orbital fill-in diagram for fluorine. Now, is that really that bad? Not really that bad. Alright, now, there's a principle that says that when one electron spins one way, the other one has to be spinning the other way. For a ticket, can somebody tell me which one that was? There is a principle, there's 3 principles. Hunn's, alpha, and what was that other one? Hunn's, alpha. A-U-S-B-A. Pauli exclusion, that's it. Okay. So, which one, did you have your hand up this year? Which one was it? No, it's Pauli exclusion. Which is what you said. Yeah. So,
Look at his notes.
I couldn't remember the word if you told me what it was. Alright, so, you have to know on the test, we made the test yesterday, you have to know these 3 things. So, let's make sure you got it. So, first of all, Pauli exclusion, number 1. Electrons in the same orbital, write this down, have different spins. That means one arrow goes up and the other goes down. I know you haven't written this down yet because I'm currently physically writing it down, so you need to be writing them down. Have opposite spins. I'm going to put OPP because we're down with OPP. Just kidding. Spins instead of opposite. That was funny, and I don't care that you didn't. Thank you. Okay, what is the rule? Or did y'all see how I put up, then down? What's the rule that says they can't share until they have to? Which person is that? Holler it out. It's not alpha. Mine just said here. No, it don't have to be up first. You can draw down first. Okay, so 2. Hunn's rule. Hunn's rule, that's the name of it. Electrons fill orbitals one at a time until they have to share. One at a time until they must share. Now, what we did on the test was we gave some of these to you, okay? And then, like, imagine this one wasn't here and you had those 4 like that. That would be wrong. You'd have to put this one in here, okay? Now, the last one is electrons fill energy levels from low to high. And so that means you have to start at 1s and go up this way. So number 3 is the alpha principle. So electrons fill energy levels. Energy levels from lowest to highest. That means that you have to fill the 1s before the 2s gets filled up. And then you have to do the 2p next, from lowest to highest. Okay. I'm going to do one, well, I want you to do one more. Actually, yeah, we'll do one more, just one more. I'm not going to do 2 because you do have some practice. Let's all do one more together. I need to show you one that has a D block, okay? So we're going to do chromium. Here we go. We're going to do chromium, and then we can actually abbreviate this. We can actually, like, do the noble gas for it, okay? So I'll show you how to do that. Okay, so for chromium, I'm going to write the electron configuration, but I'm going to do the short one. What's the noble gas above chromium, y'all?
Argon.
Yep. So I'm going to go argon, and then I'm going to say 4s2, 3d, 1, 2, 3, 4. So when you write the orbital fluid diagram, it can go argon, and then how many lines do I need to, or orbitals do I need to draw for 4s? 1. Now think before you speak. There are 10 electrons in the D block. How many orbitals do I need to draw? Yes, you're so smart. Okay. 1, 2, 3, 4, 5. Now, because of the, okay, here's these 2 electrons, by the way. 1, 2. See, Pauli exclusion, 1 up, 1 down. That's basically the way you can remember it is one that spins up excludes the other one from being able to spin up. Anyway, and then because of Hund's rule, look, don't do this because it's wrong. Look at me. Lizzie. Don't do this because it's wrong. Do not do this. That's wrong because of Hund's rule. Hund's rule, I just think of a weird dude named Hund on a bus, and like I ain't gonna sit in the seat with him until I got to. That's how I remember Hund's rule. Okay? So Hund's rule, like somebody would guess.
Why did you do 5 again?
Because the D block is 10 across. And I know I don't need all 5, but it's still gonna draw them all. You still gotta draw all of them. So 1, 2, 3, 4. Hund's rule, go one at a time. And then I did the 4S and all that before I did 3D because they're lower. And that's the off-valve principle. So that's it. You feel okay about it?
Yeah.
Yeah? Okay, so now you can go back to that other worksheet that you had. Let me explain something. Tomorrow at the beginning of the class, I'm going to check this. You need to have this the first page, front and back, all of it done, because now you know how to do it, okay? Now, the key will be up on the blog. It's the last file in one, or I'll put it up on the screen and then after you get it. Go. Do the short version for half. If you did the short version for the ones on the front, do the short version here. If you do the long version, do the long version. You need to be able to do both because I'm going to put you up to do both. And it's not multiple choice. Yep.
Sorry, the quiz.
The quiz tomorrow is just over protons, neutrons, electrons, isotopes, ions, and like the number 2 on the do now where you got to multiply and add them up. So average atomic mass. That's what's in the quiz tomorrow. Okay? So this is not the quiz. That's on the next quiz, which I think is maybe that Monday. Alright, that's it. Be busy. If you don't finish, you have homework.